Again, here we're going to use compound angle identities. So the question was cos 65 times cos 295 minus sine 115 degrees times cos 205. Okay, now as I told you yesterday, when you see acute angles, don't touch them. Okay, leave them as they are. So that cos 65, we don't do anything to it. But we have to convert the cos 295 to an acute angle, that 115 to an acute angle, and the 205 to an acute angle. So I wrote it there, it's cos 65 degrees, this is in the original question. Then 295 is in the fourth quadrant. Okay, 295 is the same as 360 degrees minus 65 degrees. So in the fourth quadrant, cos is positive, so you end up getting positive cos 65 degrees. Okay, then sine 150 is the same as 180 minus 65 degrees, so you get sine 65, but because there is a minus here, we put that minus there. Is that okay with everyone? Right, then the cos 205. Now 205 is in the third quadrant. Okay, so it's the same as 180 plus 25 degrees. So that will give you minus cos 25 degrees because cosine is negative in the third quadrant. Right, so we'll get this whole step. Okay, then we need to simplify it. So the first two, I have to rewrite them as they are. Okay, I'll probably show you a second method to carry on here. Then the minus 65 degrees times minus cos 25 will give you a positive sine 65 times sine 65 because I converted the cos 25 using ratios to sine 65 degrees.
What you did cos 25 on top of the previous?
You see this
Yes.
205. It's in which quadrant? Third. So if you use your knowledge of reduction from last year, right? Cosine of 205 degrees is the same as cosine of 180 degrees plus 25 degrees. And this will give you minus cos 25 degrees. Okay? So that's how I got that. And then this cos 25 is the same as sine 65 degrees. Then, well, there is more than one way of carrying on after this step, after that whole step. So I decided to use one of the compound angle identities for cosine. Okay? Yes? Because this minus here and that minus will end up making us say the what? The plus. Okay? So I decided to convert this, the first cos 65 to sine 25. And I kept the second cos 65 as is. Then I also converted the sine 65 to cos 25. Okay, well, you might say this is a repetition here, but I realized when I was doing the question because I was not doing the question using a memo. Okay, so it was from my head. Then I converted the sine 65 then to cos 25 so that I can use the compound angle identity number 3. Okay, now once I did that, I have this whole step. Okay, and that expression is interesting because it is exactly like the third compound angle identity, which is the first one for sine that we got. So eventually what I did was I identified my alpha and my beta. So I said let my 25 degrees be the alpha, the 65 be the beta, because here there's a product of sine and cos, and the angles they both add up to 90, and here as well. We've got product of sine and cos, angles add up to 90 degrees. Okay? Now you could also swap this whole expression so that it becomes first. Okay? But you end up having a bigger angle as compared to that. But still, if you do it the way that I did, you still get the same result. So my alpha is 25, my beta is 65. So I added the 2 and I got sine 90, which is a special angle, and the final answer will be a 1. Now this is not the only way of doing the question. Okay? You could also use the fundamental identity from grade 11 if you don't want to use the compound angle from this step. What do you notice in this step here? What do you notice? So I can write that whole expression as cosine of cos squared of 65 degrees plus sine squared of 65 degrees, and this will give you 1. So you go via that way. Okay. And I want to remind you that all your grade 11 trig is required when you're in metric. All of it. The grade 10 trig and the grade 11 trig, they're extremely important in metric. Okay? And, okay, whilst my mind is too fresh, from this year for you guys, things have changed slightly. Okay? The geometry, the tree will contribute about 33% of your paper. So about 50 marks out of 150 will be on tree. Okay? So it's a very, very important section. If you want to pass metric with a good maths mark, be a master of trig. Then the geometry will be 40 out of 150. There is no way that you can get an A, a B, or probably a C without knowing those two topics, the geometry and your trig. Because they contribute 90 marks, which is about 60% of the paper. It's only on those two topics. That's how important they are. And you have seen me when I taught the geometry, I did get like a negative vibe and said geometry is difficult, geometry is difficult. I never used that word because I don't believe that it is. Okay. If you were taught before by someone who had that negativity, I don't have that negativity. Know your theorems, know your stuff. When you're done, your trig, know all your concepts from grade 10, especially the grade 11, because most of the trig is taught in grade 11. That's where the backbone of trig is, grade 11. So if you forgot some stuff, I can even give you an ebook for grade 11. I got 2 of them. That's the math that you use class 8, 9, 8, 6, grade 11. You can use them as the resources to refresh yourself. Once you pass metric maths, you'll be smiling next year. Yeah, you have a choice of which university you want to go to. In fact, the universities would want you more than you want to go. Because of passing maths, that's the important difference. And you have the opportunity to go to the top universities. As I've told all my matrics in the past, UK is not the top university in the country. Okay. It's not even in the top 3. Okay. So the ball is in your court. Alright? So let me carry on. Right. Exercise 2. Exercise 2. Right. Exercise 2 is a continuation of application of compound angle identity. Right. Exercise 2 says prove the following. Right. Prove the following. Right. I chose the first one because it's a little bit easier, so we can start with an easy question. Now this is the proof. So you choose the side which is easier to simplify. So for 1A, it's better to simplify the left-hand side. Because the right-hand side is already simplified and it's very complex to break up. So I chose the left-hand side. So I say cos alpha. I use my knowledge of compound angles. In this case here, I've got cos alpha plus beta. So I use number 2 there. Okay? I expanded using number 2, so I got cos alpha times cos beta minus sine alpha times sine beta. That's the expansion of that. Okay? That's the expansion of that. And then cos alpha minus beta, that's number 1, which I called the mother when I first introduced this before you started the match test. So cos alpha minus beta, I did the expansion here. Let me use the blue one. That's the expansion because of space issues. So it becomes cos alpha times cos beta plus sine alpha times sine beta. Okay? Then if you look at it carefully, you find that this expression here, or that term rather, this term minus sine alpha times sine beta, okay, and plus sine alpha sine beta, they are going to cancel out because their signs are opposite. So we have a minus here, and there we've got a plus. So they'll cancel out. When they cancel out, you'll be left with, you will be left with cos alpha times cos beta plus cos alpha times cos beta. They are like terms and they are adding each other. So you end up getting 2 cos alpha times cos beta. Therefore, the left hand side will be equal to the right hand side.
Yeah.
Yes.
How do you get the sine?
Which side?
When you at the second step, you did explain that this.
I use the compound angle identities for cos. These two here.
Oh, oh.
I use those two. Do you see that we have got cos alpha plus beta? That's number 2. And here I've got cos alpha minus beta. That's number 1. So I expanded. Okay? Remember I told you when you write the examination, these 4 will be provided. But it's always wise to have them in your head because it increases your speed when you're writing. Okay? But they are provided. The rest is just simplification which has to take place. Are you following?
Yes.
Okay. Let me move on to another example.
Yes.
And there are a number of them where it fits as well. Okay. Right, let me carry on. And some I use it into. Right, 1C. Right, cosine of 45 degrees minus theta minus sine 45 degrees minus theta is equal to square root of 2 times sine theta. Now this is a proof, right? So you can see that the right hand side is simplified. So you have to simplify the left hand side. So straight away I chose the left hand side, then I used the compound angle for cosine, number 1 there, which is called the mother, based on how I taught you. So cosine of 45 degrees minus theta can be written as cos 45 times cos theta plus sine 45 times sine theta. So this is the expansion of that. Okay? Then sine 45 degrees minus theta, that's its expansion. It will be sine 45 times cosine of theta minus sine theta times cos 45 degrees. But before I did that, I had to take into account this negative because you can make a silly mistake because of that negative. So I put that negative outside and I put the expansion inside brackets. Okay, because this minus here, it affects everything inside the brackets, or rather, it affects the expansion of that. So I had to put the minus outside the brackets and write my expansion inside the bracket. Okay? Then cos 45 is the same as 1 over square root of 2. Please, it's not, okay, it is correct to say root 2 over 2, but it's a sign that you might have used the calculator. So it's 1 over square root of 2 times cosine of theta plus the sine 45 is the same as cos 45, that's 1 over square root of what? Of 2 times sine of theta. Okay, so I'm done with the simplification of the first part. Okay, which is the expansion of cosine of 45 minus theta. Then I put my minus, this one here, right? This minus Okay, I've got the sine 45, so it becomes minus 1 over square root of 2 times cosine of theta. This negative times that negative there will give me a positive, so I end up having the positive here. Okay, then cos 45 is a special angle, so that's 1 over square root of 2 times sine theta. So that's that whole step.